Morning, nerds. So here we are, the greenhouse effect. So we're starting to move on to what are natural things that happen in the environment. And the greenhouse effect is natural to what are things that we are starting to impact in the environment. Okay, so what's the point? Basically, you want to be able to, by the end of this, define the idea known as the greenhouse effect, okay? You're also going to want to be explaining some of the causes of it, that's for sure. But the potential impacts we'll probably get into a little bit here, but we're going to leave some of those for class. All right, so what do you need to remember? You need to remember that the atmosphere is made up of a variety of gases, but these include both, this is carbon dioxide, methane, water, so water vapor. All right, so what is the greenhouse effect? Basically, it's a natural process that helps warm the surface of the Earth. If it wasn't for the greenhouse effect, there would not be able to be life on Earth as we know it. It would have to be something different. So when the sun's, because it just wouldn't be hot enough. So when the sun's energy reaches the Earth's atmosphere, okay, so some of it's reflected back into space. The rest is absorbed and re-radiated by greenhouse gases. So when we say the sun's energy, we mean in particular what we call the long wave radiation or infrared light. Infrared light is what we call heat. Okay, so the heat that travels through from one thing to another. So the heat that bounces off, normally it would, if it wasn't for the greenhouse effect, they would all be bounced straight out of the atmosphere. Whereas these ones, they hit certain molecules and they cause them to gain energy. Okay, so they absorb it. So for example, this is a molecule of carbon dioxide, so you've got two oxygens, one's carbon. It gets hit with the energy and it starts to vibrate in all different ways, depending on where it's hit, how it's hit, etc. So it gets hit with the radiation and it starts to vibrate, which means it's absorbing the energy. But then it can't hold on to the energy for too long, so it re-radiates it back out. Now, what that looks like is the radiation was going out. Now, as I said, most of this would be reflected back out, but some of it, so it hits the CO2 molecule, and so we'll draw two there. So two bits of radiation hit it, it vibrates for a little while, and then it re-radiates them out in all different directions, which means some of that, a certain percentage of that, comes back to Earth. Now, that's what this looks like. So first, solar radiation is reflected by the Earth and the atmosphere, okay? So it comes down, some hits the atmosphere, it bounces away. Most is absorbed by the Earth's surface, okay? So here we go, one. So most radiation is absorbed by the Earth's surface, cool, and it warms it up. As it gets warm, it then emits infrared radiation back out into the atmosphere, okay? So back out into space. However, some of the infrared radiation passes through the atmosphere just fine, goes back into space, but some's absorbed and re-emitted. So as we said here, it gets absorbed by the particles and then re-emitted in all different directions by greenhouse gas molecules, and those are some of the ones we mentioned at the beginning. So this basically warms the surface of the Earth and the lower atmosphere, so it warms everything below. Greenhouse gases, they act like a blanket. Well, they act like a greenhouse for plants, so you can grow plants in winter. But they act like a blanket for the Earth, trapping the heat in. So let's have a look at what human-enhanced greenhouse effect is. So here it is regularly. Solar radiation comes down, re-radiated heat goes out, most goes back into space, but some is sent back down to Earth to just keep us warm. But yet you've got the human enhanced. So you see you've got more greenhouse gases than you had before. So it's much higher levels, which means more heat is re-emitted back down, less escapes into space. So now we're going to look at the sources of carbon dioxide. Okay, so the green ones here actually take it out. Okay, so we've got renewable fuels take in and out. Photosynthesis takes it out of the atmosphere. Land sinks take it out of the atmosphere, and biological and chemical processes remove some. That's fine. Now, This BMT is billion metric tons. So we've got, for instance, that's like what, 200? And if we're looking at just, there's roughly 150, which is going in and out naturally. But everything on this side, these are all human induced. So these are the ones which are causing the human enhanced greenhouse effect. There we go. Struggled there for a second. That's the human enhanced greenhouse effect is caused by these ones. All right. So this is not a new idea, not by any stretch. It's often treated as a new idea in the media, and we'll get to that in a coming episode. But it's not a new idea. So Savant Arrhenius, who's an extremely famous and important chemist, is a Swedish scientist, a Swedish chemist. He first came up with the idea that the greenhouse effect, which was an idea that was a solid 150 years old before that stage, that the greenhouse effect was a global effect. It used to think that if you burned a lot of carbon dioxide, or burn a lot of things to release carbon dioxide in a local environment, it would heat up that local environment. That was not under contention. We've already knew it happened, but he always sort of showed that it became a global event. So he claimed that burning the fossil fuels may result in enhanced global warming, which it has. He also found the average surface temperature of the Earth was 15 degrees Celsius. This was actually quite a big thing. This took him about 10 years to work out. And it was higher than anyone else had expected. And this was because of the increased infrared absorption capacity due to these. When I say higher than expected, higher than anyone expected due to natural greenhouse gases. He suggested that a doubling of the carbon dioxide concentrations, which is the biggest one, like that's the main one, would lead to a 5-degree temperature rise. And that's it. So that's kind of where we end up for that one. And yes, see you in class.